to fix this concept about invariance. Look. I have the space R3. Then I have, for instance, X, Y, and Z. Okay? This is a point here. Suppose my temperature, okay, X, Y, Z, is equal, let's put 4 degrees Celsius. Okay? Now, if I move my axis, this is X prime, this is Y prime, and this is Z prime. So the temperature here is invariant. Okay? That's the same temperature here. Okay? T, X prime, Y prime, and Z prime. So the temperature at this point here is invariant. It does not depend on the time. I will talk again later using this crucial, fundamental concept of invariant. Okay? Now let's come to the side of the board. Okay? I'll raise here, erase here. Definition. You see, no question. Dot product. The dot product of two vectors A and B, okay? A and B. Let's put here, A and B. You see, here I don't show the coordinates. Doesn't matter. I don't talk about coordinates over here. See? So the dot product is the vector A dot B. The definition, okay, is the modulus of vector A, modulus of vector B, cosine of this angle over here. Why? No why, by definition. In general, okay, I use to the notation. See, I put A here without arrow and B without arrow, just to tell you that is a modulus or intensity of the vector A. By definition, cross product, see, it depends on the coordinate system. Vector C, A cross B. A cross B, by definition, A cross B, it is a vector. By definition, dot product B dot A dot B, where the dot product of two vectors is a scalar quantity. You're going to see later that the dot product not always will be a scalar. Okay? But when I have two vectors, okay, then it will be a scalar quantity. Cross product is not a scalar, it's a vector. By definition, A cross B. The size of this product is AB sine alpha. Sine alpha. By definition again. You see? But because C is a vector, the size of A cross B is not enough. See? I have to define the direction because it's a vector. So the direction, you see, this is a plane. Plane containing A and B. It will be vector C, okay, that is defined like I rotate A to reach B, see? Then I have rotate like this, okay? In this case, counterclockwise, okay? So C is a vector perpendicular to the plane pi formed by the vectors A and B. See? So vectors A and B, okay, characterize a plane that contains these two vectors. I'll give an example like this, just for you to understand. You see? I have vector A, I have vector B. You see? There is only one plane that contains these two vectors. See? So, if suppose he's A, the blue one is A, the black one is B. If I rotate, you see, here is the plane, the vector C will be perpendicular to this plane over here, by definition. That's why B cross C, I'm sorry, B cross A is a vector minus C, clearly, see? Because if I rotate B to reach A, this will be minus C, see? That's repeating, showing here, you see? This blue is A, the black is B. I rotate, I have C. If B cross A, if I rotate, you see, I have negative C. That's very, very important. And this I call attention, A, B belongs to the plane P, the plane P, pi. Okay? C is perpendicular to both A and B. This is a note. Note that B cross A is minus C, right here. Now, A dot B, A cross B, and this is a mixed product. Mixed product, I have A cross B, I just dot product with another vector V. Attention now. Don't put parentheses. You don't need right here. You don't have to put like this. Don't use this. You don't need, because if you don't put the parentheses, there is no V scalar A. V scalar A is a scalar. Is a scalar cross B. It's nonsense. Okay? There is no definition. The definition of cross product is not a scalar cross. That's why this is redundant. You see, you have to first calculate A cross B and then make the dot product with the vector V. Also, I didn't talk there, but it's important that A, B is equal to B, A. This doesn't matter. But I will emphasize A cross B is equal minus B cross A. See? That's very important. Okay? Because here is scalar. Okay? The A dot B is equal B dot A. A cross B is equal minus B cross A. So that's our lecture 4. And please like or dislike, share. Because it's important for me to spread this knowledge that I'm putting in the board to as much as we can to reach students, undergraduate, graduate students. And subscribe on my channel, Carlos Thompson, YouTube. And to contribution, if you want, to the channel, to reinforce the channel, is just my PIX 327-533-737-87.